Alright, I'm going to start with a quick run through of one-player mode, and two-player mode will be in the next segment. This is going to be more focused on showing off all the gameplay elements, so I made a couple changes that I'll revert in the final. I'm going to start with a high score so that when I die I can show off the high score input. I'm also going to spawn scorpions earlier than usual so that I can show off their behavior and the poison centipede behavior. There's a quick run through of two-player mode. quick explosion rundown. I have 4 separate explosion objects, one for just enemy explosions, one for spiders specifically because they need to have their own system for creating the little score that pops up when you kill a spider, or they need to interact with other systems rather. One for when the ship gets destroyed, and then one for the explosion effect during mushroom regen. Other than that, though, they effectively all function the same. They just appear on screen and then play through the animation, and once the animation is finished, just get destroyed. Alright, for my ship, I tried to create them using factories, but that led to too many complications with having them be controlled by the correct player controller. So what I did instead was have my game manager just have a reference to one ship instance that gets created on startup, and then all the controllers just use that. I made 2 controller classes, one for player, one for AI. The ship movement is dictated by a series of flags it contains that just state is it supposed to be moving in a certain direction, and if so it does. The player controller manipulates those via input, sets them when the correct keys are pressed, and then unsets them when the associated keys are released. The AI controller is a little different. Obviously it doesn't take raw input, but when you give it control it just sets the up and the left flag so it starts moving, and then every frame it essentially just checks is the ship about to hit a bound of the player area, and if so it just has it invert directions. This is defined within the ship, but it's only called from the AI controller, so it never does it on its own. In terms of setting and releasing control, that's just done through these give and release control functions. To give a player controller control, it just registers input and then deregisters it when it's released, because all my player instances are always live. You just don't want them all controlling it at once. And my ship update doesn't do all that much. It just checks those flags and then clamps itself to its position, updates its sprite, all that good stuff. One thing I do want to clarify is I don't have it set to collide with mushrooms directly. Since I know mushrooms are never going to move, what I do is when it's about to move in a direction, I just check like, is the cell it's going to end up in have a mushroom in it? And I make sure that it doesn't before I actually do the movement. Just a little optimization there. Alright, this is my bullet. I don't have it always live following the player. I just create it when it gets fired and then destroy it when it goes off screen. It's a really simple update. All it does is just update its position and then check if it's off screen. Like the ship though, I don't have it set to directly collide with mushrooms or with any blocking text. For optimization, what I do instead is just after it changes position, get the cell it just entered and then check if there's something in it that should block the bullet. Destroy it after that, and then if it's a mushroom specifically, deal damage to it. This bullet is factory generated, which I will demonstrate real quick. So the AI ship is going to try and fire a bullet right away. Checks to make sure there's no bullets on screen. And it's the first one, so it'll create a new one. And when I try and fire one again, or after however many times there's available bullet instances, so it pulls one of them and uses it instead. Alright, so this is my centipede rundown. I have the parent class, then a derived head class, and a derived body class. Most of the data members that both classes need is the same, so I have them inside the parent. And I also have in here a function that is responsible for leaving behind a mushroom when the segment dies, because that's the same for either type of segment. I'm going to run through the movement processing as this all occurs in the head. The head only has a variable that checks what distance has been traveled since it last checked if anything needed to move. And every frame you just decrement from that how much it actually moved by. And once that reaches 0, you start the processing. This cell in and cell last in, each segment keeps track of the cell it was currently in and the cell it was last in, and it makes those blocked so that other centipedes can't run into it. It saves a reference to the movement state it was just in, and then determines its next one from there. In order to chain this through the body, it just has each segment do the same thing pretty much. It saves what state it was just in, gets its new state, and then the one after it, which is the next segment in the list, it'll tell that one to do the state that it was just doing, and just change that until the entire list is processed. All of this right here is just handling any churn animations. This horizontal and vertical direction, these are enums that I have associated with each state that just say, is it a left and right state or is it an up and down state? Then when you change states, if there's a mismatch between the direction of the state you were just in and the direction of the state you're going, you have to flip the sprite accordingly. Also on each segment, I have it block the cell that it was just most recently in. And at the very end, I have the cell that the last segment was most recently in unblocked. You don't need to unblock it until then, because a new segment is gonna enter where you just were anyway, so it's still gonna be blocked. That is basically all I have in the update for the head, aside from just updating its position and its sprite. The body is the same, it just does the sprite and position updating. I do have this weird thing that checks like if it's in a turn animation, if it needs to switch out of it, it does. It's weird, but I wasn't able to think of a way around this. I'm gonna run through a couple get next states real quick. For any of the downward moving ones, it does check for poison every time. Again, something I wasn't able to work around. If that fails, it checks if it is either blocked by something or if it's at the edge of the screen. If that is not the case, it keeps going in the state it was in. Otherwise, it chooses a way to turn from there. The unblocked state I check first because that's significantly more common than the blocked state, and the up moving states do the same thing, except they don't have to check for poison. Both of these are factory created as well, which I will now demonstrate. So the first head gets created, creates a new head, then the first body segment gets created, creates a new body. Just to show you what this looks like on the screen. And the create body segment will get called a bunch more times. So that's 11 new segments right there. And when I start the next level, it will use the head that was just recycled from the previous level, and then do the same for all of the body segments. Until there's no more available. Alright, this is my mushroom rundown. Each mushroom keeps track of how much health it has and whether or not it's poisoned, so obviously I incorporate poison and not poison all into one class. The way I do that is when I poison it, I mark it as such and move the texture rectangle down into the bottom row of its sprite sheet, which has all the poison sprites in it. And then when I regen the mushroom, I just reset its health, mark it as unpoisoned, and then reset the sprite, which just moves the texture rectangle back into the top row of sprites, which is the non-poison row. Just show off factory regen real quick. So the AI level is going to create the first mushroom instances in the game. These are all in the same frame, so it's all going to be new ones. And it just does that like 35, 40 more times. And when I start the new level, it'll spawn all of them, but it should mostly or all, depending on how many I have set to get generated at the beginning of the level, because it's random. It's a range like 35 to 40. They will all be recycled ones. Alright, for my mushroom field, this mushroom cell class is kind of the basis of it. Each instance just corresponds to one 16 by 16 square in the game field. It keeps track of where it is, whether or not it has a mushroom. And then these two bools are for determining whether or not they're blocked for centipede movement. This is set whenever a mushroom is spawned or whenever glyphs are spawned. For example, this is like all the text that shows up in attractor mode, like credits and bonus every 12,000 and stuff. As those get created, like it'll communicate with the cell they were just in to block them. My mushroom field class, each player has one of their own, and it's essentially an array of mushroom cells that spans the size of the entire game field. Operations on individual cells are done within here, but operations on the field as a whole are done through this mushroom manager class. This might be like regen, for example. So my regen is done in kind of a cycle in order to achieve the delay between mushrooms being repaired. The first time you call it, it will start from the bottom left and then just work its way up and to the right. But each subsequent time you call it, it'll be called from the cell you were last left off at, which is what this prev I and prev j right here represent. The first cell that you find that has a mushroom that needs to be repaired, it will do so on mushroom, resets all the variables it needs to, and then it creates this mushroom repair animation class to go along with it. When the end of the animation of that repair is reached, it calls back to the manager to start the scan over again from where you most recently were, and when it finds the next mushroom, it just repairs it and keeps going. Alright, it's my scorpion class. Pretty simple, just updates its movement and its sprite every frame. I do not have it checking for a mushroom every single frame. What I do instead is similar to what I did for the centipede head. I just have it keep a counter of how long it's been since it last checked for a mushroom. And once that counter has spanned the size of a cell, I then check if the cell it's currently in has a mushroom, and if so, poison it. I don't need to check whether or not the mushroom's already poisoned, because all this function does is just mark its poison flag and change its sprite. So if it's already poisoned, it's not going to do anything, so I don't need to waste an if there. Demonstrate its factory real quick. Obviously, my AI level is not going to have scorpions in it in the final product, but I just marked them as on for this demonstration so I can show off the factory. So it'll create one right away, create the new one. That'll regen in like a few more seconds. And now it reuses the instance that was just created. This is my spider rundown. It'll destroy any mushroom it touches. I do have that with just standard collision. I tried to implement a method where it would use like the rectangle of the spider and just check like the corners of it to determine when mushrooms got destroyed, but it would just pass right over them sometimes, so that didn't work. Its movement is handled by a state machine, kind of the same way that the centipede is. It just, once it travels, I think it ends up being every 2 cells or so. It determines a new state to go in, and its position is just updated by the X and Y vectors of whatever state that is. For any states that are a right moving state, when it chooses the next state, essentially at random, it will only pick from states that are also going to the right. Likewise, when it's a left-facing state and it picks a new one, it will only pick states that go to the left. In terms of the straight up and down movement, I have like 2 separate states for that, where it's like one is up but about to move left, and one is up but about to move right. And then the same for downward movement, which I have to make that distinction so that it can only choose the correct horizontal movement in those states. Alright, quick flea rundown. I do not have it checking for mushrooms every frame, much like every other enemy type. I just have it keep track of how long it's been since it last checked if it needed to create a mushroom. And once it detects it's traveled the size of a cell, it'll try and create one then. I just don't give it a 100% chance of creating a mushroom so that it's not a continuous trail the whole way down. When it actually tries to create one, it will check if the cell it's in already has something blocking it before it actually creates it. And then just to show off the factory real quick. So the factory obviously doesn't actually create the flea, or even try to, unless there's not enough mushrooms in the player field. This is a variable it gets from the wave manager. I just have the number set super high right now so you can see the factory in action. Obviously, first flea of the game. And now every time after, it'll use the recycled one. Right, so for enemy spawning, I don't actually have separate enemy spawner classes. I just centralize all of it within each factory. The reason for this is if I do a separate enemy spawner for each class, that's just what the factories already are. And if I have one enemy spawner class for all of them, that won't work if we need more than 5 enemies, because each one needs to be spawned on an alarm, and each game object can only hold 5 alarms, so at that point we would have to create separate enemy spawner classes just for that, which wouldn't really make sense in my opinion. So these alarms are instead contained within each factory because it only needs one. When they are triggered, I have a state for each factory. It's just either active or inactive. It's inactive whenever the player is dead because you can't have enemies spawning during regen, or it's inactive when it's a wave that doesn't allow the enemy type to be spawned to begin with. It will call upon the create spider function of that state. If it's the active one, it just calls back to the factory that it needs to actually do the spider creation. If it's the inactive state, it doesn't do anything. This alarm will then get set again by this start spawn timer function right up here, which the spider will tell the factory that it needs to call when it either gets killed or goes off a screen. In terms of setting the spawn rate and whether or not it can even spawn to begin with, that is done in this spider manager class right here. Every time that a wave begins, it will set whether or not it can spawn, whether or not how often it'll spawn, how fast it moves, etc. And then it also sets the active state based on from the wave data file whether or not the enemy type is set to be able to spawn for this wave or not. This way there's no ifs or anything involved in the creation of spiders. It's just based on the state type, and this is essentially the same implementation I have for all the other enemies as well. Alright, so this is my wave manager. It contains all the pertinent information for each wave, such as how long the centipede should be, how fast spiders should move, whether or not certain enemies should be able to spawn, etc. It stores all of that for every wave in the game. This information is stored within these arrays right here that are set to be the length of however many waves they're specified to be. In order to actually obtain this data, it calls this set wave data, which only gets called once during load all resources. This is the type of file that it is expecting. It expects this format where it is a parameter name on one line and then right below it is the value for it. If it's not set up in this format, it just doesn't do anything for that particular token. So it'll go through each line in the file, check if it's a parameter of any sort, and if so, call the correct function in order to actually set it. And each function has with it, it makes sure that it's the correct type of parameter as well. So, for example, if it's looking for a number for speed, it won't let you put in like a string or like a mixture of numbers and letters. It makes sure no invalid data gets put in that way. In terms of wave maintenance, making sure the correct wave data gets spawned for the correct wave, there's three main functions for that. There is this initialize wave. This gets called anytime a new game begins or when it switches back to AI mode from a game over. There's restart wave, which is called in one player mode when you die because you don't need to do as much functionality because you know you're not going to change player. There's also this change wave right here, which is the same thing except for two player because you need to switch which player you're currently on before you reset all the wave data. Alright, so this is my player parent class with AI and human player classes derived from it. The objective with this is to create a centralized object that information that's relevant to each specific player can be stored, such as what their current score is, what their mushroom field is, what level they're currently on. Operations on this are controlled through my player manager. This has a reference to all the players that are currently active in the game. Player 0, or an array, sorry. Player 0 in the array is designated as the AI player. All the other ones are humans. contains some really important utility functions such as this get current player, so any other systems that need to interact with the current player can get it through there instead of going to it directly. You can retrieve the AI player for setting up the AI scene when you switch to it. There's also functions for advancing and reversing the players, which are needed for 2-player mode when you change wave and when you check for which player you need to go to next in the event of a game over. I make use of the flyweight pattern just using the sprite sheet and glyph classes that you provided for us. Each separate string on the screen, such as like the score for each player and what amount of lives each player has, is contained within a string subclass of its own. So like there's one for a score display, one for a life display, one for high score names and values, etc. Each one of these classes has a list of glyphs that corresponds to the glyphs that are like what is being shown on screen. And when this list of glyphs for each one gets changed, it pushes or deletes them from this text draw manager, which contains a list of all the glyphs that need to be drawn from all the substrings, which will just draw them once every frame. For the strings that have a mutable value, such as the scores, it only actually changes them when they need to be changed, not just every frame. For example, a score display has like update functions associated with it. Like this one will only be called when the player it's connected to actually scores, which I'll demonstrate in a moment. The exceptions to this rule will be the high score display and like the set of all the high score displays and the attractor mode specific text, such as like the 2 credits and bonus every 12,000, etc. So it's created the necessary score glyphs right now. It's currently drawing them. And now that I've gained a point, it's going to go and flush out all the glyphs from the old display, removing them from the text draw list while it's at it, and then go through and create a new string, a new substring, which it then pushes back into the glyph list, keeps it current. Alright, so this is my sound manager. It uses kind of a pseudo command pattern. It doesn't take sound commands, it just takes like raw sounds themselves, although it functions the same as the command pattern. Anytime a sound needs to be added to the queue, this queue sound gets called on the sound manager from whatever class actually contains the sound. The sound manager has a state, one for muted, one for unmuted, and this push sound function gets called on it from there. If it's in the muted state, it doesn't do anything. If it's in the unmuted state, it'll call back to the sound manager and say, actually push the sound into your queue, and then every frame they all get played. I only have one instance of each state. It is defined in this sound manager, declared in this sound manager state instances file, and then defined in the sound manager state parent CPP file. And whenever the state needs to change, it just gets a reference to the state that it needs to be in, rather than creating a new instance every time. Alright, so this is my score manager. This contains all the values of all the scores that correspond to each score adding event, such as an enemy dying or a mushroom getting repaired. This makes full use of the command pattern through these score command objects. Each one is essentially just a class with a amount of points associated with it and an execute command that generally just adds that amount of points to whatever the current player is. Whenever a new command needs to get processed, the send score command gets called from whatever object contains the score, and the sound manager or the score manager state handles it from there. There is an active and an inactive state for my score manager, since if you're in AI mode, you don't need to do any score processing because there's no player being scored, so it's just more of an efficiency. If you're in the active state, it will then queue the command into the score command queue. If it's inactive, it doesn't do anything. And then from there, it just goes through and executes all the commands. Like the sound manager, I only have one instance of each state. The same applies for the instances of each command itself, because the no matter what enemy instance it is or what mushroom it is or whatever, they all have the same behavior when the command gets sent, so there's no need for multiple copies of the same one. Alright, for my high score, the display of it on the AI mode is handled by this high score display class, which just contains an array of high score name and value substrings, which based on just random names and values provided at runtime, and then any other gained high scores after that build the necessary glyphs. The values for the names and scores are maintained in this high scores and names classes right here, which just has an array of 8, like I said, random ones at beginning. If you were to beat a score, the game manager will check for that every time you die. If you do beat one, I have a separate class which handles the input of the score at the time. There's 2 objects, one that just holds what the score is and the name for it, and also what number score it is. When you create that, it creates a separate object with it that actually handles the input of the new name. Once enter is called on there, it will send a signal back to the high score containing object that you put in a name for it, which will then call back to the high scores and names class and actually set the new score and the new name, and then bump down all of the original scores so that yours will be reflected in there. This does only last on the runtime of that particular game, though. Once you exit out and reload the game, your score will be gone.